There is a moment, quiet and immeasurably vast, when the universe feels less like a place and more like a question. As your breath softens into a slow, drifting rhythm, imagine standing at the edge of everything you know, stars scattered like ancient whispers, galaxies turning in silence, and between them, a darkness so deep it defies comprehension. This is not the universe of textbooks or telescopes. This is the unknown universe, the hidden architecture that stretches far beyond the reach of light, thought, or imagination. What lies in that darkness is not emptiness, but possibility. As your awareness deepens, picture the observable cosmos shrinking beneath you, the billions of galaxies, the swirling nebulae, the scattering of starlight becoming only a small island in a sea too vast to map. Most of the universe cannot be seen, not because it is distant, but because it is made of something we cannot detect directly. Dark matter forms invisible scaffolds where galaxies cling and grow, shaping cosmic evolution with a gravity we feel but cannot touch. Dark energy stretches space itself, accelerating expansion in a way that makes the universe grow more mysterious with every passing moment. In this unseen realm, the familiar rules begin to blur. Imagine drifting through intergalactic space, where silence has no meaning because there is nothing to carry sound, and light becomes rare photons, traveling for billions of years between solitary encounters. As your mind softens, see the cosmic web spreading across the universe like a delicate network of glowing filaments, connecting clusters of galaxies through strands of gravity. This structure, grander than anything on Earth, arises from forces we barely understand. In its presence, human concerns feel small, yet the wonder it inspires feels infinite. Beyond the cosmic web lie regions forever hidden from us, the parts of the universe where light will never reach Earth, expanding faster than its signals can travel. As your thoughts drift further, imagine these unreachable domains, each one a self-contained cosmos with its own galaxies, stars, and perhaps even worlds. We will never see them, never measure them, yet they exist, shaping the boundaries of what is knowable. The unknown universe is not just far away, it includes everything we will never be able to witness. And deeper still, beneath galaxies and stars, space is not empty but restless. Quantum fields ripple with fluctuations. Particles appear and vanish in instants too brief to name, and space-time stretches and curves with invisible tension. As your awareness sinks into a calm, expansive quiet, imagine these subtle tremors, the fabric of reality shimmering as if breathing. This quantum restlessness seeds entire universes, drives cosmic inflation, and forms the foundation on which stars will one day burn. The unknown universe exists not only in distance, but in the smallest vibrations of existence itself. Yet through all this mystery, the paradox is simple. The more we discover, the more the unknown expands. Every galaxy mapped reveals 10 more uncharted. Every theory solved exposes new questions. Every glimpse into the cosmic dark invites us deeper into its silence. As you drift gently into this vastness, allow the unknown to feel less like something to fear and more like an invitation, an open horizon where wonder grows unbounded. Because in the end, the unknown universe is not merely out there, it is the space where curiosity awakens, where imagination thrives, and where the human spirit finds its endless night sky. Light is our only messenger across the cosmic vastness, yet it travels to us slowly compared to the size of the universe. As your breath settles into a calm, drifting rhythm, imagine a single photon leaving a distant galaxy. its journey beginning long before humans existed, before Earth had oceans, before even the sun was born. It travels through expanding space for billions of years, carrying with it the story of a place that may no longer exist. When it finally reaches your eyes or a telescope, it becomes a fragile echo of the universe's distant past. Everything we know about the cosmos rests on these ancient whispers of starlight. As your awareness deepens, picture the observable universe as a sphere centered around you, not because you are special, but because light has reached you from that distance and no further. Its boundary lies about 46 billion light-years away in every direction, forming a horizon not of matter, but of knowledge. Beyond this limit, galaxies drift away faster than light can catch them, pulled by the accelerating expansion of space. They slip beyond visibility, not because they vanish, but because the universe's growth outpaces the speed of its own information. The edge of sight is not the edge of existence. The light we do capture reveals only a fraction of what surrounds us. As your mind softens into deeper calm, imagine the cosmic microwave background, the faint afterglow of the Big Bang stretching across the sky like a fabric woven from ancient heat. It is the oldest light we can see, a boundary beyond which photons could not travel freely. This soft radiation carries the imprint of the universe just 380,000 years after its birth, showing tiny temperature variations that would one day become galaxies, stars, and planets. In its subtle glow lies a silent map of cosmic childhood. Yet even within the observable universe, mysteries linger. Vast regions appear darker, emptier, and more silent than expected. Some are cosmic voids, expanses where few galaxies formed. Others hold structures so large they challenge our understanding of cosmic evolution. As your awareness deepens, imagine drifting through these voids, where stars grow rare and darkness stretches for unimaginable distances. The emptiness is not hostile, it is simply part of the universe's grand architecture, shaped by forces we cannot entirely explain. Light also bends as it travels, curving around massive objects due to gravity. This bending gravitational lensing reveals invisible structures by distorting the shapes of distant galaxies. As your thoughts drift further, imagine clusters of dark matter forming invisible lenses in space, magnifying the light passing near them. Through these distortions, astronomers map unseen mass, revealing an underlying skeleton that holds the universe together. The light we see carries messages not only from luminous objects, but from the shadows around them. And beneath all of this lies the profound truth. The universe we perceive is only the universe that light allows us to see. Its true extent, its hidden regions, its unreachable horizons all lie beyond our current vision. What we call the observable universe is merely the illuminated island within an immeasurable ocean. As you drift gently deeper into stillness, allow this idea to rest softly in your mind. We are surrounded not by emptiness, but by possibility, by regions we can never witness, stories we can never read, and a cosmos that forever extends beyond the furthest horizon of light. Most of the universe is made of something we cannot see, cannot touch, and cannot produce on Earth. As your breath eases into a deep, gentle rhythm, imagine drifting through a galaxy not as it appears in photographs, bright spirals of stars and dust, but as it truly is, a luminous swirl floating inside a vast, invisible halo of matter. This unseen substance, dark matter, outweighs all visible stars and planets combined. It forms the gravitational framework that holds galaxies together, guiding their rotation and shaping their evolution. Without it, the the cosmos would unravel into scattered points of light. As your awareness deepens, picture dark matter as a kind of cosmic lattice, an enormous, three-dimensional web stretching across the universe. Galaxies are not randomly scattered. They cling to this dark framework like dew forming along threads of an invisible spiderweb. Clusters of galaxies gather where this web is densest, while vast voids expand between its filaments. Though we cannot observe dark matter directly, its presence is unmistakable in the way galaxies move, the way light bends, and the way structures form across billions of light years. It is the silent architect of cosmic geography. Dark matter does not interact with light. Photons pass through it without slowing, scattering, or illuminating it. As your mind sinks deeper into calm, imagine drifting through a dark matter halo, the space seemingly empty, yet filled with a mass that shapes everything around it. It pulls on stars, planets, and gas clouds, creating gravitational patterns we can measure but never witness. It is everywhere and nowhere, influencing the universe while remaining hidden behind a veil of perfect transparency. One of the most profound clues to dark matter's existence comes from galaxy rotation. Stars at the edges of galaxies orbit far too quickly to be held in place by visible mass alone. As your awareness softens, imagine these stars racing around galactic centers, their speed defying the gravity of the luminous matter we can see. Only an unseen substance, vast in quantity and evenly distributed, can explain their motion. Dark matter forms the invisible glue binding galaxies across cosmic time. Gravitational lensing offers another glimpse into its presence. When light from distant galaxies passes near dark matter, it bends, stretches, and warps. This distortion reveals the hidden mass shaping the cosmic landscape. As your thoughts drift further into quiet, imagine these warped images, arcs, rings, and smeared reflections painting the silhouette of dark matter across the sky. Through these distortions, we trace the outline of something that does not shine, yet dominates the universe. And through all of this, the paradox becomes clear. The substance that forms the skeleton of the cosmos is something we have never directly detected. Dark matter is both real and unreal, measurable yet invisible, influential yet untouchable. It carries the weight of galaxies while remaining perpetually hidden. As you drift deeper into stillness, let this truth settle gently in your mind. The universe we see is only the surface. Beneath it lies a vast, unseen structure, asterisk, asterisk, the unknown universe, asterisk, asterisk, supporting everything, shaping everything, and reminding us that the greatest forces are often the ones we cannot see. The universe is not only expanding, it is speeding up. As your breath falls into a slow, drifting rhythm, imagine distant galaxies, not gently drifting away but accelerating outward, pushed by a force that permeates all of space. This mysterious pressure is called dark energy, and it makes up nearly 70% of the entire cosmos. It does not shine or pull or interact with matter in any familiar way. Instead, it stretches the fabric of space itself, causing every distant point in the universe to move farther from every other. The expansion is not happening at the edges, it is happening everywhere, in every direction, in every moment. As your awareness deepens, imagine space as a soft, flexible fabric, smooth, silent, and infinite. Dark energy acts like a gentle but persistent wind blowing through this fabric, causing it to swell and expand. Yet this wind has no source, no direction, no tangible presence. It is the universe behaving in a way that defies intuition. The more space expands, the more dark energy seems to exist, and the faster expansion continues. It is a feedback loop with cosmic consequences. In the distant future, galaxies will drift so far apart that only local clusters will remain visible, isolated islands in a dark ocean of expanding space. Scientists discovered dark energy by observing distant supernovae stars that explode with brilliant intensity. As your mind softens, imagine these stars acting like cosmic mile markers, each one revealing that the universe is expanding faster than predicted. The discovery was shocking, challenging decades of assumptions about gravity and cosmic structure. If gravity pulls everything inward, why is the universe accelerating outward? The answer remains unknown. Dark energy is not a force we understand. It is a behavior we observe, a mystery wrapped into the mathematics of space-time. Even the nature of dark energy remains elusive. Some theories suggest it is an intrinsic property of space, a constant pressure woven into the vacuum itself. Others propose it changes over time, pulsing through the universe in ways we have yet to detect. As your awareness deepens, imagine standing on the threshold of knowledge, looking out at a cosmos expanding faster than light can travel. The universe is not only bigger than we thought, it is stranger, governed by rules that seem to contradict the familiar physics of everyday life. The accelerating expansion also shapes the universe's ultimate fate. If dark energy continues to strengthen, galaxies will drift apart until their light can no longer reach one another. Stars will fade, matter will cool, and the cosmos will stretch into a faint, silent emptiness. As your thoughts drift into deeper calm, imagine this distant future not as a moment of destruction, but as a quiet diffusion, the universe exhaling into infinity. Dark energy becomes the conductor of cosmic destiny, guiding everything toward an outcome we cannot yet fully understand. And through all of this, the paradox persists. The greatest force shaping the cosmos is one we cannot see, touch, or measure directly. Dark energy is everywhere and nowhere, powerful yet undetectable, expanding the universe while leaving no trace of its own nature. It is the purest expression of asterisk asterisk, the unknown universe asterisk asterisk, a reminder that even with all our knowledge, the cosmos remains a mystery far deeper than our understanding. As you drift gently into stillness, allow this mystery to open rather than close, inviting you to rest in the wonder that the universe is not finished revealing itself. The universe is not filled with stars. It is filled with emptiness, vast, silent territories so large that entire galaxies disappear within their scale. As your breath falls into a calm, unhurried rhythm, imagine drifting beyond the glowing filaments of the cosmic web into regions where light grows thin and galaxies become rare. These are cosmic voids, immense bubbles of near-nothingness, spanning hundreds of millions of light-years. Their darkness is not hostile. It is simply untouched, a stillness so complete that it challenges the very idea of what space should be. In these voids, time feels slower, distance stretches deeper, and the universe reveals its most mysterious form, absence. As your awareness deepens, picture the cosmic web surrounding these voids like luminous threads. Galaxies gather along the edges, forming clusters and superclusters, leaving behind great hollow chambers of almost pure vacuum. These voids are not perfectly empty. They contain a sparse sprinkling of atoms, dust, and dark matter. Yet compared to the richness of galactic regions, they are desolate kingdoms. Their very existence raises questions. Why did matter avoid these regions? What early cosmic fluctuations carved out such enormous hollows in space-time? To float through them is to drift through the universe's forgotten rooms. Voids are so vast that even light, traveling at perfect speed, takes hundreds of millions of years to cross them. As your mind softens into deeper stillness, imagine a single photon beginning its journey from one side of a void. For eons it travels uninterrupted, never encountering a star, planet, or cloud, only expanding darkness. When that photon finally reaches a telescope on Earth, it carries with it the record of a journey through one of the most untouched environments in the cosmos. In its silence, the void preserves a purity that dense regions of space can never offer. Yet these empty regions are anything but insignificant. Voids expand faster than denser regions because gravity has less material to pull inward. As your awareness deepens, imagine the walls of a void stretching outward like a cosmic breath, while the surrounding filaments tighten and condense under their own weight. This interplay shapes the large-scale structure of the universe, allowing galaxies to cluster more tightly while voids widen further. The universe evolves not only through matter, but through the dance between presence and absence growth, fueled by emptiness itself. Within these voids, the laws of physics remain the same, yet their expression feels different. With so little matter present, particles travel freely, radiation cools without interruption, and the expansion of space becomes more noticeable. As your thoughts drift further, imagine how a lone galaxy inside a void would live its life, isolated from its neighbors, evolving slowly, quietly, untouched by the bustling interactions at the cosmic web's borders. These lonely galaxies exist, faint and rare, revealing how profoundly environment shapes cosmic evolution. And in all of this, the paradox echoes softly. The universe is defined as much by its emptiness as by its substance. The voids, the silent chambers between galaxies, give shape to the cosmic web, guiding matter into the patterns we observe. They are the breath between the beats, the darkness that reveals the light, the unknown spaces that make the visible universe meaningful. As you drift deeper into calm, allow this truth to settle gently within you. To understand the cosmos, one must understand not only what is there, but what is not. For in asterisk, the unknown universe, silence is as important as starlight. The universe we see may not be the only one. As your breath settles into a slow, floating rhythm, imagine the cosmos not as a solitary expanse, but as one bubble in a vast cosmic ocean, a single universe drifting among countless others. This idea, known as the multiverse, suggests that our reality is only one version of existence, shaped by physical laws that could differ entirely elsewhere. Some universes might be filled with stars and galaxies. Others may have collapsed instantly or expanded too quickly for matter to form. In this vast landscape, our universe becomes one possibility among infinite, a fragile island of conditions that allowed life to emerge. As your awareness deepens, picture space itself undergoing inflation, an explosive expansion in the earliest fraction of a second after the Big Bang. During this moment, quantum fluctuations may have caused different regions of space-time to inflate at different rates, creating separate universes like bubbles drifting outward from a cosmic foam. Each bubble would be sealed from the others, its laws of physics fixed by the conditions of its birth. Our universe is one such bubble, expansive, stable, and filled with the structures we call stars, planets, and galaxies. Some theories propose an even stranger idea, that new universes are born inside black holes. As your mind softens into deeper stillness, imagine the core of a collapsing star forming a singularity, where density becomes infinite and space-time curves beyond comprehension. In certain models, This singularity may not be an endpoint, but a doorway giving rise to a new expanding universe on the other side, with different constants, particles, and structures. If this is true, then every black hole in our universe could contain its own cosmos, unseen and unreachable. Quantum physics adds yet another layer to the mystery. At the smallest scales, particles behave as if they exist in multiple states at once, superpositions that collapse only when observed. Some interpretations suggest that every collapse represents a branching of realities, with each outcome forming a new universe. As your awareness deepens, imagine an endless tree of possibilities, each decision, each fluctuation, each random event creating alternate worlds. In this view, our universe is not singular, but layered, an infinite labyrinth of histories unfolding simultaneously. The multiverse also raises profound questions about existence. If infinite universes exist, then every possible arrangement of matter may occur somewhere. As your thoughts drift deeper into quiet, imagine versions of the cosmos where galaxies never formed, where stars burn twice as hot, where planets are covered in oceans of methane, or where life evolved into forms we cannot imagine. Some universes might be too chaotic for structure, others too simple for complexity. The multiverse is not a theory of abundance, it is a theory of infinite variation. And through all of this, the paradox emerges gently. The more we understand about our universe, the more likely it seems that it is only a fragment of something larger. If the multiverse exists, then everything familiar, time, matter, physics, even reality itself, becomes one expression among many. Our existence becomes both ordinary and astonishing, a natural consequence of cosmic diversity. As you drift deeper into stillness, allow this truth to rest softly in your mind. Asterisk, asterisk, the unknown universe. Asterisk, asterisk, may be far greater than we ever imagined. Not a single stage, but an endless theater where countless realities unfold, each with its own story written in the silence of space. A black hole is not merely an object, it is a place where the universe forgets the rules it once followed. As your breath settles into a slow, effortless rhythm, imagine drifting toward a region where gravity becomes so intense that space curves downward like a deep well. Light bends, time stretches, and everything familiar begins to distort. At the center lies a singularity, a point of infinite density where matter is compressed beyond understanding. In this realm, the known laws of physics collapse, leaving behind a mystery so profound that even the brightest minds can only describe its edges, never its interior. As your awareness deepens, picture the event horizon, the boundary separating what can be seen from what can never return. It is not a surface, not a wall, but a one-way threshold where escape becomes impossible. A photon, generated just inside the horizon, will never reach the outside universe. Even time itself moves differently there. To an outside observer, anything falling toward the horizon appears to slow, freeze, and fade into darkness. But to the falling object, the journey continues, swift and silent, into the unknown. This duality is one of the strangest paradoxes in cosmology. Inside a black hole, space-time is so severely curved that all paths lead inward. As your mind softens into deeper stillness, imagine following one of these paths, a trajectory that does not allow turning or pausing. Gravity is not merely a force here, it becomes the shape of existence itself. Space flows like a river toward the singularity, carrying everything with it. The deeper you go, the stronger the current. In the final moments, physical concepts lose their meaning. Length, time, mass, even identity dissolve into a state where no known equations apply. Black holes are also engines of creation. Around them swirl accretion disks, rings of superheated gas glowing brighter than entire galaxies. As your awareness deepens, imagine these luminous whirlpools feeding the black hole while simultaneously launching jets of charged particles across interstellar distances. These jets shape galactic evolution, influencing star formation and distributing energy across thousands of light years. In this sense, black holes are not destroyers but sculptors, guiding cosmic structure through processes far more complex than simple consumption. Even information behaves strangely near a black hole. Quantum theory suggests that information cannot be destroyed, yet classical physics predicts that anything falling into a black hole is lost forever. As your thoughts drift into quiet contemplation, imagine this tension, two pillars of science pulling in opposite directions. This conflict gave rise to the famous information paradox, a puzzle that challenges the foundations of physics. Some theories propose that information is encoded on the event horizon. Others speculate that it escapes through Hawking radiation. Yet no answer is certain. Black holes guard their secrets with perfect silence. And through all of this, the core paradox persists. Black holes are the most extreme expressions of gravity, yet they may hold the key to unifying quantum mechanics and relativity. They are cosmic abysses and cosmic laboratories, swallowing matter yet illuminating galaxies, erasing information yet revealing new physics. As you drift deeper into stillness, allow this thought to settle gently within you. In asterisk, the unknown universe, asterisk. Black holes are not merely dark, they are the gateways where our understanding ends, and something far greater begins. When a massive star collapses but does not become a black hole, something extraordinary is left behind. A neutron star, an object so dense that a single teaspoon of its material outweighs mountains. As your breath settles into an easy, unhurried rhythm, imagine drifting toward this remnant, a sphere only about 20 kilometers wide, yet possessing more mass than our Sunday. Gravity has crushed atoms until electrons and protons fuse into neutrons, creating matter in its most compressed form. Here, on the threshold between existence and oblivion, the universe reveals what happens when matter is pushed to its absolute limits. As your awareness deepens, picture the surface of a neutron star, smooth, hard, and impossibly dense. A pebble dropped onto its crust would strike with the energy of a large explosive. Magnetic fields twist around it with unimaginable strength, billions of times greater than anything Earth can produce. These fields shape charged particles into streams that accelerate near the speed of light. In silence, these invisible structures carve patterns through space, turning the neutron star into a kind of cosmic lighthouse whose beams sweep across the sky. These beams create what we call pulsars, rapidly rotating neutron stars whose radiation flickers like a perfectly timed cosmic heartbeat. As your mind softens, imagine a pulsar spinning hundreds of times per second, its pulses so regular that they rival the precision of atomic clocks. For distant civilizations, pulsars would serve as natural cosmic beacons, marking the structure of the galaxy with their unwavering rhythm. Their existence is a reminder that even in the aftermath of destruction, the universe continues to generate order and structure. But beneath the surface lies an even more mysterious world. As your awareness deepens, imagine the matter inside the neutron star compressed so tightly that individual neutrons begin to break apart. In the deepest layers, quarks, the fundamental building blocks of matter, may flow freely in a state known as quark-gluon plasma, similar to the conditions moments after the Big Bang. No laboratory on Earth can recreate this environment. These stars become windows into physics that predates atoms themselves, offering glimpses into the earliest moments of the universe. Collisions between neutron stars produce some of the most spectacular events in the cosmos. As your thoughts drift deeper into calm, imagine two neutron stars spiraling inward, radiating gravitational waves that ripple across space-time. When they finally merge, they forge heavy elements: gold, platinum, uranium, scattering them through the galaxy in brilliant explosions called kilonovae. Everything from jewelry to the metal in spacecraft carries the signature of these ancient collisions. Neutron stars are not only remnants of destruction, they are factories of creation, enriching the universe with elements essential for life and technology. And in all of this, the paradox shines clearly. Neutron stars are both tiny and massive, stable and explosive, remnants of death, yet engines of cosmic birth. They challenge our understanding of matter, revealing states of density and pressure far beyond anything we can comprehend. As you drift gently into stillness, allow this truth to rest softly within you. Asterisk, asterisk, the unknown universe, asterisk, asterisk, is not only vast in space, but in the very nature of matter itself. In these compact stars, the cosmos teaches us that creation continues even in the shadow of collapse. In the deep reaches of space, farther than any ordinary starlight can travel, there exist objects so luminous that they outshine entire galaxies. As your breath softens into a slow, drifting rhythm, imagine gazing across the cosmos to a point of light that has been traveling toward you for billions of years, a point brighter than 1,000,000,000,000 suns, yet smaller than our solar system. These are quasars, cosmic lighthouses powered by supermassive black holes in the early universe. Their glow is not starlight, but the brilliant flare of matter spiraling into darkness at unimaginable speeds. As your awareness deepens, picture a distant galaxy in its infancy, its center dominated by a black hole millions or billions of times the mass of the Sunday. Gas and dust swirl around it in a blazing accretion disk, heated to extreme temperatures as it spirals inward. Magnetic fields twist this hot plasma into colossal jets that shoot outward at nearly the speed of light, piercing intergalactic space. This energy, released by matter falling toward oblivion, becomes one of the brightest phenomena the universe has ever produced. Through quasars, black holes reveal not their silence, but their fury. Quasars serve as ancient barcodes written across the cosmic timeline. As your mind settles into deeper calm, imagine their light traveling through expanding space, passing through clouds of primordial gas. Each cloud leaves a tiny fingerprint, a faint absorption line on the quasar's spectrum. By studying these lines, astronomers decode the history of the early universe, its temperatures, its chemical evolution, its large-scale structure. Quasar light is a messenger carrying stories across more than 10 billion years, offering glimpses into epochs long before the Milky Way took shape. Though quasars appear small in the sky, their influence is enormous. As your awareness softens further, imagine the jets shooting from their centers, carrying energy far beyond their host galaxies. These jets heat surrounding gas, slow the formation of new stars, and shape the growth of galactic structures. Quasars regulate the evolution of their environments, acting as cosmic thermostats. Without their bursts of energy, galaxies might become too large or too dense. With them, cosmic balance is maintained. Their brilliance is not random, it is a crucial part of the universe's design. Eventually, As quasars exhaust their fuel, their light fades. The accretion disk cools, the jets dissipate, and the galaxy settles into a quieter state. As your thoughts drift into deeper stillness, imagine these ancient beacons dimming one by one as the universe grows older. Most quasars existed when the cosmos was young, during an era of intense growth and transformation. Their disappearance marks the shift from a turbulent early universe to the calmer, more structured cosmos we see today. Their brilliance is a memory of youth, of a universe still learning to form itself. And through all of this, the paradox becomes clear. Quasars are powered by destruction, yet they illuminate creation. They are born from the darkest objects, yet they shine with unmatched brightness. They exist in the most remote regions, yet they reveal the deepest truths about the universe's past. As you drift gently into quiet, allow this thought to settle softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, is not only defined by darkness, but by the extraordinary light that emerges from it. Light that travels across cosmic ages to reach us, carrying the silent story of everything that came before. Galaxies do not drift through the universe alone. They gather into vast families bound by gravity. As your breath settles into a gentle, unhurried rhythm, imagine floating above a cluster of galaxies, hundreds or even thousands of spiraling, glowing islands, each containing billions of stars. These clusters are among the most massive structures held together by gravity, their sheer weight bending space-time and sculpting the cosmic landscape. In their presence, the scale of the universe becomes almost incomprehensible, stretching far beyond any sense of distance we know on Earth. As your awareness deepens, picture the hot, glowing plasma that fills the space between these galaxies. This intergalactic medium, heated to millions of degrees, emits X-rays that reveal the scale and shape of the cluster. Yet even this luminous gas accounts for only a fraction of the cluster's mass. Most of it lies invisible, embedded in a vast halo of dark matter. This unseen structure acts as the skeleton of the cluster, guiding the motion of galaxies and anchoring the web of gravity that holds them together. Without it, clusters would simply disperse into emptiness. Clusters themselves are not isolated. They assemble into even larger formations known as superclusters, enormous regions where galaxy clusters link together in chains, sheets, and filaments. As your mind softens into deeper stillness, imagine these superclusters forming the cosmic web, a grand pattern stretching across billions of light years. This web is the universe's large-scale blueprint, a map shaped by gravity, expansion, and the subtle interplay of dark matter and ordinary matter. Every galaxy, every star, every planet exists within this intricate arrangement. These structures evolve slowly across cosmic time. As your awareness deepens, imagine galaxy clusters drifting through the cosmic web, merging with one another in titanic collisions. When two clusters collide, the energy released is unimaginable. Hot gas slams together. Galaxies pass through mostly untouched, and dark matter halos interpenetrate with ghostly silence. These mergers create shockwaves that ripple across millions of light years, heating gas, shaping magnetic fields, and altering the balance of the cluster. Even in the vast emptiness of space, motion and change never cease. Gravitational lensing reveals these structures with remarkable clarity. The mass of a galaxy cluster bends the light from distant galaxies, distorting their shapes and magnifying them. As your thoughts drift deeper, Imagine observing a distant galaxy stretched into a delicate arc by the gravity of a cluster in the foreground. These distortions act as natural telescopes, allowing astronomers to peer deeper into the universe while simultaneously mapping the dark matter within clusters. The universe becomes both lens and subject, revealing its structure through its own gravity. And through all of this, the central paradox persists. The universe appears empty on small scales, yet overwhelmingly structured on large ones. Galaxies cluster, clusters connect. Superclusters weave together into a cosmic lattice so vast that light itself struggles to cross it. As you drift gently into quiet, allow this truth to settle within you. Asterisk, asterisk, the unknown universe, asterisk, asterisk, is not random. It is a masterpiece of organization written across immeasurable distances. In its immense architecture, the cosmos reveals both its complexity and its elegance, inviting us to contemplate the grand patterns that shape all existence. Stars are not born in silence. They emerge from clouds of gas and dust so vast that thousands of solar systems could fit inside them. As your breath softens into a slow, drifting rhythm, imagine entering a nebula, a luminous cloud glowing with delicate hues of pink, blue, and gold. These colors come not from paint or flame, but from energized atoms releasing light after being struck by radiation from nearby stars. Within this cosmic mist, gravity pulls particles together grain by grain, forming dense regions where new suns begin to grow. The birthplace of a star is both chaotic and serene, a quiet storm sculpted by forces older than time itself. As your awareness deepens, picture tiny ripples forming inside the nebula regions where gas becomes slightly denser than its surroundings. Over millions of years, these ripples collapse inward under their own gravity, heating up as pressure increases. Hydrogen atoms begin to collide, releasing faint warmth that slowly intensifies. Eventually, the core becomes so dense and hot that nuclear fusion ignites. This moment marks a transformation of unimaginable significance. A star is born, a furnace capable of shining for billions of years, illuminating planets, shaping galaxies, and creating the heavy elements needed for life. Nebulae come in many forms, each revealing a different chapter in the story of star formation. As your mind softens further, imagine drifting past a dark nebula, an immense cloud blocking starlight behind it. These dark shapes hide clusters of forming stars, their light not yet strong enough to pierce the dust. Beyond them lie emission nebulae, glowing brightly with energized gas, and reflection nebulae, shimmering softly with scattered starlight. Each type represents a different interaction between light, matter, and gravity. Together, they form a cosmic nursery where stars are constantly born and die. The dust within nebulae contains the building blocks of planets, moons, and living organisms. As your awareness deepens, picture microscopic grains of carbon, silicon, and icy molecules drifting through space. These tiny particles collide gently, clumping into larger and larger structures. Over millions of years, they form planetesimals, then protoplanets, and eventually full worlds with oceans, atmospheres, and mountains. Every planet that exists began as a whisper of dust in a star-forming nebula. Even the atoms in your body, carbon from ancient stars, oxygen from supernovae, originated in these glowing nurseries. Star formation also shapes the structure of galaxies. As young, massive stars burn brightly, they release intense radiation and powerful stellar winds. As your thoughts drift deeper into stillness, Imagine these winds carving cavities into the nebula, creating arcs, bubbles, and filaments of glowing gas. When massive stars die as supernovae, they send shock waves through surrounding clouds, triggering new generations of star formation. The birth and death of stars form a continuous cycle, weaving the galaxy into a dynamic tapestry of creation and renewal. And through all of this, the paradox becomes clear. Nebulae are clouds of dust and gas so cold and dark that they seem lifeless, yet within them burn the beginnings of suns, planets, and life itself. They are both emptiness and abundance, silence and explosion, shadow and brilliance. As you drift gently into quiet, allow this truth to settle softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, hides its greatest wonders inside the faintest clouds. In the quiet glow of a nebula, the cosmos creates the light that will one day illuminate worlds. A star's life is long, but not eternal. As your breath settles into a soft, drifting rhythm, imagine a massive star nearing the end of its shining years. For millions of years, it has fused hydrogen into helium, radiating warmth and light into the vastness around it. But eventually, its fuel begins to dwindle, its core contracts, and pressure builds to unbearable extremes. In the final moments, the delicate balance between gravity pulling inward and radiation pushing outward collapses. The star trembles, falters, and then within a heartbeat of cosmic time, it explodes in a brilliant supernova, one of the most powerful events in the universe. As your awareness deepens, picture this explosion expanding through space like a luminous wave. The shock front travels outward at thousands of kilometers per second, sweeping up gas, dust, and magnetic fields. The star's outer layers, once peacefully drifting in stellar winds, are now hurled across light years. This blast is so bright that it can outshine an entire galaxy for a brief moment. The light from such an event can travel billions of years, reaching distant worlds and ancient civilizations long after the star that created it has disappeared forever. A supernova is both an ending and a message, a final brilliant signature of a star's existence. But within its destruction lies creation. As your mind softens into deeper quiet, imagine the interior of the dying star, where extreme temperatures and pressures forge the heavy elements the universe cannot create any other way. Gold, silver, uranium, iodine, iron, these elements, the building blocks of planets, oceans, and living beings, are born in the heart of a collapsing star. When the supernova releases them, they scatter across the galaxy, seeding nebulae with the materials needed for new worlds. Every atom of iron in your blood, every calcium atom in your bones, was once forged in a star that ended in fire. Supernova remnants drift for millions of years, shaping their surroundings. As your awareness deepens, imagine a glowing shell of gas expanding outward, cooling slowly as it interacts with interstellar material. These remnants become catalysts for new star formation, compressing nearby clouds until gravity takes over, igniting the birth of the next generation of suns. The cycle continues endlessly. Stars form, shine, die, and give rise to new stars. The universe is not static. It is a living ecosystem of cosmic recycling, fueled by the deaths of giants. Supernovae also serve as cosmic milestones, helping astronomers measure the expansion of the universe. Type Ia supernovae, produced by white dwarfs reaching a critical mass, explode with near-uniform brightness. As your thoughts drift deeper, Imagine these supernovae acting like cosmic lighthouses, their consistent luminosity allowing scientists to calculate distances across billions of light years. Through them, we discovered the accelerating expansion driven by dark energy. These distant explosions quietly reveal the fate of the cosmos. And through all of this, the paradox glows softly. Destruction becomes creation, death becomes birth, and endings become the seeds of new beginnings. Supernovae are not just catastrophes, they are the universe's way of renewing itself, scattering the ingredients of life across the stars. As you drift gently into stillness, allow this truth to settle within you. Asterisk, asterisk, the unknown universe. Asterisk, asterisk thrives on cycles, where even the brightest deaths illuminate the path toward future worlds. Long before galaxies formed, before stars ignited, before atoms even assembled, the universe was a searing ocean of heat and light. As your breath settles into a slow, drifting rhythm, imagine the early cosmos, a dense, glowing plasma where photons scattered endlessly, unable to travel freely. For nearly 400,000 years after the Big Bang, this brilliant fog filled all of space. But as the universe expanded and cooled, atoms finally formed, allowing light to break free. That ancient light still travels today. It is the cosmic microwave background, the oldest radiation we can observe, a faint whisper of creation itself. As your awareness deepens, picture this primordial light stretching across the entire sky, invisible to human eyes, yet detectable with sensitive instruments. Its temperature is just a few degrees above absolute zero, uniform in every direction except for tiny fluctuations. These small variations, barely 1 part in 100,000, carry within them the blueprint of the universe's structure. They reveal where matter was slightly denser, where gravity would begin pulling material into the seeds of galaxies, and where the first cosmic threads of the large-scale structure would emerge. This ancient light is not smooth. It carries a delicate, mottled pattern. As your mind softens, imagine these subtle temperature differences as gentle ripples on the surface of an endless sea. Over billions of years, these ripples grew into galaxy clusters, superclusters, and the vast cosmic web. The cosmic microwave background is therefore not merely a relic, it is a map of the universe before structure existed, a portrait of reality in its infancy. Reading this map allows scientists to infer the age, shape, and fate of the cosmos. The uniformity of this radiation reveals something extraordinary. The early universe was remarkably smooth, with matter and energy distributed almost evenly. As your awareness deepens, imagine how surprising this is. Regions now separated by vast distances too far apart to have ever exchanged light or heat nevertheless share the same temperature. This mystery led to the theory of cosmic inflation, a brief moment of exponential expansion in the first fractions of a second after the Big Bang. Inflation stretched tiny quantum fluctuations into the seeds of galaxies, imprinting the cosmic background with patterns we now observe. Over time, the cosmic microwave background has faded and cooled as the universe expanded. Once a brilliant glow, it is now a faint, cold radiation permeating all of space. As your thoughts drift deeper into calm, imagine this ancient light washing gently over everything: stars, planets, galaxies, and even you. It passes through your body at this very moment, carrying information from a time when the universe was young and glowing. Every second, billions of these ancient photons move through you, silent and unnoticed. And through all of this, the paradox becomes clear. The faintest light in the universe is also the most important. It reveals the earliest moments of existence, the seeds of cosmic structure, and the mechanisms that shaped everything we see today. It is both unimaginably old and always present, both weak and incredibly informative. As you drift gently into stillness, allow this truth to settle softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, leaves clues everywhere, even in the quiet glow of light born at the dawn of time. Planets begin not as worlds but as dust, tiny grains drifting within vast disks of gas swirling around young stars. As your breath settles into a slow, gentle rhythm, imagine approaching one of these protoplanetary disks, glowing softly in the light of a newly formed sun. The disk stretches outward like a cosmic ring, filled with microscopic particles of ice, metal, and rock. These grains collide and cling together, forming clumps that slowly grow larger. What begins as a cloud of dust becomes the first step in the creation of entire worlds. As your awareness deepens, picture these small clumps colliding again and again, sticking together through static forces and gentle impacts. Over millions of years, they grow into planetesimals, mountain-sized bodies, drifting silently through the disk. Their gravity strengthens as they grow, pulling in more material. As your mind softens into calm, imagine these planetesimals merging through slow, stately collisions that reshape their surfaces and alter their trajectories. In these quiet interactions, the architecture of planetary systems takes form. Some regions of the disk become dense enough for runaway growth to begin. As your awareness deepens, imagine a protoplanet forming a body large enough to attract gas, dust, and smaller planetesimals. This infant world grows until it becomes a massive core, capable of forming rocky planets like Earth or gas giants like Jupiter. Gravity sculpts its shape, heat builds in its core, and its surface begins to evolve. These early planets are fiery, chaotic, and unstable, but they hold the potential for oceans, continents, and atmospheres yet to come. The remaining gas in the disk plays a vital role in shaping a planetary system. As your thoughts drift deeper, imagine gas giants forming in the outer regions, their massive gravity carving gaps in the disk. Their migration, slow and powerful, reshapes the orbits of smaller planets, scattering some, capturing others, and creating a final configuration unique to each star system. No two planetary systems are alike. Each one is a cosmic experiment shaped by chance, gravity, and timing. Eventually, the disk dissipates as the star's radiation clears away the remaining gas. As your awareness deepens, picture the newborn planets emerging from the thinning cloud, their orbits settling into long-term stability. Some worlds cool and harden, forming crusts and oceans. Others retain thick atmospheres of hydrogen and helium. Some become icy moons, desert planets, volcanic spheres, or frozen giants. The diversity of planets in the universe is a testament to the complexity of their birth. And through all of this, the paradox becomes clear. Planets are born from chaos, yet they create environments where order and even life can flourish. They begin as dust, but become homes for oceans, atmospheres, and living beings. As you drift deeper into stillness, allow this truth to settle within you. Asterisk, asterisk. The unknown universe, asterisk. Asterisk is constantly shaping new worlds, turning scattered particles into places where light can fall, water can flow, and life may someday awaken. Planets were once thought to belong only to our solar system, but the universe has revealed a far more abundant truth. As your breath settles into a slow, drifting rhythm, imagine the night sky not as a scattering of distant stars, but as a collection of suns, each one possibly encircled by its own family of worlds. These exoplanets, orbiting stars light years away, come in every form imaginable: scorching giants hugging their suns, frozen spheres drifting in darkness, and rocky worlds that may hold oceans beneath soft, blue atmospheres. The cosmos is no longer just stars. It is a vast archipelago of possible homes. As your awareness deepens, picture the ways we detect these distant planets. One method, the transit technique, measures the faint dimming of a star as a planet crosses in front of it. As your mind softens further, imagine a distant sun flickering ever so slightly, just enough for astronomers to know that a world has passed by. Another method, radial velocity, senses the tiny wobble of a star pulled by a planet's gravity. These delicate clues allow us to measure size, mass, temperature, and even atmospheric composition. From such subtle signals, entire worlds materialize out of darkness. Some exoplanets orbit within the habitable zone, where temperatures allow liquid water to exist. As your awareness deepens, imagine drifting toward one of these worlds, its clouds swirling softly around a distant star, its surface perhaps hosting lakes, rivers, or oceans. Many of these planets are super-Earths, larger than our world and potentially more stable. Others are ocean worlds, covered entirely in deep global seas. The diversity is astonishing, reminding us that Earth is only one expression of planetary possibility. Atmospheres hold the key to detecting life beyond our solar system. As your thoughts drift further, imagine starlight passing through a planet's atmosphere during a transit, leaving delicate spectral fingerprints. From these fingerprints, scientists can detect water vapor, methane, oxygen, and other molecules. The presence of certain gases in combination could suggest biological activity. A single spectral pattern, hidden within the faint glow of a distant star, might one day reveal that we are not alone. The search is slow, patient, and filled with wonder. Some planets defy all expectations. As your awareness deepens, picture hot Jupiters, gas giants orbiting so close to their stars that their atmospheres boil and stream into space. Imagine tidally locked worlds where one side burns under eternal daylight while the other rests in perpetual night. Picture diamond planets, iron worlds, and rogue planets drifting without stars. Each discovery expands our understanding of what a planet can be, erasing boundaries we once thought were fixed. And through all of this, the paradox becomes clear. The more planets we find, the more mysterious the universe becomes. With each new world, we see not answers but possibilities, worlds that challenge our assumptions, expand our imagination, and deepen our curiosity about life's place in the cosmos. As you drift gently into stillness, allow this truth to settle softly within you. Asterisk, asterisk, the unknown universe. Asterisk, asterisk, is filled with distant shores we have not yet seen, each one waiting quietly in the starlight, carrying secrets that may one day transform our understanding of existence. Our galaxy is a vast, rotating island of stars so immense that light takes 100,000 years to cross it, yet so subtle that from within we see only a band of shimmering dust across the night sky. As your breath settles into a soft, drifting rhythm, Imagine rising far above the Milky Way, watching its spiral arms unfurl like delicate ribbons of starlight. Within those glowing arms lie billions of suns, nebulae, star clusters, and worlds. This galaxy is our home, but we have never truly seen it from the outside. From within, we understand only fragments of its shape, pieced together from faint clues carried across space. As your awareness deepens, picture the galactic disk, a thin, luminous plane filled with stars orbiting the center in graceful, looping paths. The Sun is one of these stars, completing a single orbit every 230 million years. As your mind softens further, imagine the solar system drifting gently along one of the spiral arms, surrounded by stellar neighbors that come and go over cosmic time. We are always moving, always migrating, carried through the galaxy by gravitational tides more ancient than humanity itself. The Milky Way is not static. It is alive with motion and change. Toward the center of the galaxy lies a dense, glowing bulge, a region crowded with stars, packed far more tightly than those near the Sunday. At its core rests a supermassive black hole called Sagittarius A*. As your awareness deepens, imagine this dark heart pulling stars into rapid orbits, some circling at speeds exceeding thousands of kilometers per second. Though it is quiet now, this black hole may have once blazed as a quasar, illuminating the galaxy with powerful radiation. Even today, faint echoes of its past activity ripple through surrounding gas and dust, hinting at a turbulent ancient history. Beyond the disk lies the galactic halo, a sparse, ghostly region filled with old stars and mysterious dark matter. As your thoughts drift deeper, imagine this halo as a vast, translucent sphere surrounding the galaxy, shaping its rotation and anchoring its structure. The stars here are relics from the early universe, remnants of ancient collisions and mergers that helped build the Milky Way long before the Sun existed. Embedded within the halo are globular clusters, dense swarms of stars orbiting in slow, majestic arcs, their origins lost in cosmic antiquity. The Milky Way itself is part of a larger community. As your awareness deepens, picture the local group, a collection of more than 50 galaxies bound together by gravity. Our galaxy dances in a slow, spiraling interaction with Andromeda, its nearest large neighbor. In 4 billion years, the two will collide and merge, creating a new, even larger galaxy. Far from being isolated, the Milky Way participates in the grand choreography of cosmic structure, shaped by forces spanning millions of light years. And through all of this, the paradox emerges gently. The galaxy feels overwhelmingly vast, yet it is only one of billions in the observable universe. It is our home, yet we occupy a tiny corner of one spiral arm, a speck within a speck. As you drift gently into deeper stillness, allow this truth to settle softly within you. Asterisk, asterisk, the unknown universe, asterisk, asterisk, begins right here. In the galaxy we call home, a place filled with mysteries we have barely begun to understand, spinning quietly in the dark sea of cosmic eternity. Beyond the soft glow of our Milky Way lies a universe filled with other galaxies, each one a vast, self-contained island of stars drifting through the cosmic ocean. As your breath settles into a slow and unhurried rhythm, imagine looking beyond the familiar star fields of our sky into realms where faint smudges of light are not stars at all, but entire galaxies millions or billions of light years away. Spirals, ellipticals, irregular shapes, Each galaxy is a unique expression of cosmic evolution, shaped by gravity, time, and the silent expansion of the universe. As your awareness deepens, picture a grand spiral galaxy like Andromeda, its graceful arms swirling with billions of stars, nebulae, and star clusters. These spirals rotate slowly, their arms outlined by glowing regions of star formation and lanes of interstellar dust. As your mind drifts further, imagine drifting above one of these galaxies, watching the spiral arms curve outward like luminous petals. Spirals are the gardens of the cosmos, nurturing young stars while preserving ancient ones in their radiant embrace. In contrast, elliptical galaxies are immense, rounded clouds of stars without the delicate structure of spirals. As your awareness softens, imagine these elliptical giants, vast, smooth spheres containing trillions of aging stars. They glow with a faint, reddish light, the mark of stellar populations long past their youthful, blue-bright phase. These galaxies are the remnants of mergers and collisions, where chaotic interactions have smoothed away structure. They drift through space like cosmic embers, glowing softly with the memory of ancient light. Then there are irregular galaxies, wild asymmetrical structures shaped by turbulence, gravitational encounters, or bursts of star formation. As your mind deepens into stillness, imagine one of these galaxies twisting and stretching, its form unsettled and dynamic. While lacking symmetry, irregular galaxies often host intense regions of starbirth, their chaotic environments giving rise to some of the brightest young clusters in the universe. Their unpredictability reminds us that evolution within the cosmos is neither uniform nor orderly. It is a story written by chance as much as by law. Galaxies rarely evolve in isolation. As your awareness deepens further, picture entire groups and clusters of galaxies interacting, passing close to one another, exchanging gas, or merging into larger structures. These interactions trigger new waves of star formation, reshape galactic arms, or create tidal tails that stretch like luminous bridges across the void. Some collisions destroy structure, while others create new order, forming elliptical galaxies or fueling central black holes. In this vast community, galaxies are not solitary travelers. They are participants in an endless cosmic dance. And through all of this, the paradox emerges once more. Galaxies are unimaginably large, each containing billions or trillions of stars, yet they are also small components of the observable universe. They are the cities of the cosmos, scattered across a landscape so broad that even light struggles to traverse it. As you drift gently into deeper quiet, allow this truth to settle softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, is not defined by emptiness alone, but by a breathtaking abundance of galaxies, each one a distant world of possibilities, shining quietly in the endless night. The universe is not static. It moves, stretches, and transforms with each passing moment. As your breath settles into a slow, gentle rhythm, imagine the cosmos, billions of years from now, a place where galaxies drift farther apart, their light stretched into faint whispers by the accelerating expansion of space. This future is already unfolding. Each second, the universe grows larger, carrying distant galaxies beyond the reach of observation. In time, only the closest cosmic neighbors will remain visible, isolated islands of starlight surrounded by infinite dark. As your awareness deepens, picture stars nearing the ends of their lives, massive blue giants will burn out first, fading into supernovae that seed the void with heavy elements. Smaller, sun-like stars will expand into red giants, shedding their outer layers before collapsing into white dwarfs, dense, cooling embers of once brilliant suns. Over trillions of years, even these remnants will dim, growing cold and dark. As your mind softens further, imagine a universe where starlight becomes rare, each illumination a precious survivor in the vast and deepening night. Galaxies, too, will evolve toward quiet. As their gas supplies diminish, the birth of new stars slows and eventually ceases. As your awareness drifts deeper, imagine galaxies settling into long periods of stillness, their shapes unchanged, their star clusters gently aging. With fewer interactions and mergers, galactic growth halts. What remains are collections of ancient stars, orbiting silently within halos of dark matter. The universe transitions from a vibrant, star-forming realm into a quieter, more contemplative expanse. In far future epochs, black holes begin to dominate. As your thoughts drift into deeper calm, imagine these dark titans growing as they consume matter around them, stars, planets, even smaller black holes. Over unimaginable timescales, they release faint Hawking radiation, slowly evaporating into nothingness. The disappearance of black holes marks one of the last energetic phases of the cosmos. What remains afterward is a landscape of cooling particles drifting through an ever-expanding void. Eventually, the universe approaches a state known as heat death, a cold, diffuse equilibrium where energy is evenly distributed and no work can be done. As your awareness deepens, imagine the fabric of space stretched thin, temperature nearing absolute zero, and motion slowing to a near stop. Particles drift without interacting, time stretches without landmarks, and the cosmos becomes a quiet, endless dusk. This is not destruction but dissolution, a gentle fading of structure into simplicity. And yet, within this solemn ending lies the paradox that defines the universe. Even as it fades, the cosmos remains vast, boundless, and full of possibility. Some theories propose that quantum fluctuations could ignite new universes within the emptiness, beginning the cycle anew. Others suggest that the universe may never truly end, but simply transform. As you drift gently into stillness, allow this truth to rest softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, holds not only mysteries of the past, but countless futures, each one unfolding silently within the infinite darkness ahead. Time is often imagined as a steady river, flowing from past to future with quiet inevitability. Yet in the universe, time is not separate from space. It is woven into the very fabric of reality. As your breath settles into a slow, drifting rhythm, imagine space-time as a vast, elastic sheet, curving gently beneath the weight of stars, planets, and galaxies. Where mass bends this sheet, time itself stretches and slows. A clock near a massive object ticks more slowly than one far from gravity's pull. This is not a metaphor, but a measurable truth. Time flows differently in different places. As your awareness deepens, picture the universe shortly after the Big Bang, when time itself began. There was no before, no empty stage waiting to be filled. Time emerged with the universe, expanding as space expanded. As your mind softens further, imagine time stretching outward in all directions, carrying matter and energy with it. The earliest instants of time were so compressed, so dense that the laws of physics struggled to take form. Only as the cosmos grew and cooled did time settle into a rhythm that allowed atoms, stars, and galaxies to exist. Time is also shaped by motion. As your awareness deepens, imagine traveling near the speed of light. To an outside observer, your clock would slow dramatically, seconds would stretch, minutes would lengthen. This phenomenon, time dilation, means that motion through space alters motion through time. Those who travel quickly age more slowly relative to those who remain still. Even astronauts aboard orbiting spacecraft experience this effect, feeling the universe reshape the way time flows through their bodies. At the smallest scales, time behaves even more strangely. As your thoughts drift deeper, imagine the quantum realm, where particles flicker in and out of existence and events lack definite order. Some theories suggest that time, at its foundation, is not continuous but granular, composed of tiny, indivisible moments. Others propose that time may be an emergent property rising from deeper patterns of quantum entanglement. In this view, time is not fundamental. It is a consequence of information unfolding across the universe. Yet despite these complexities, humans perceive time emotionally rather than physically. As your awareness softens further, imagine how memories stretch the past, how anticipation pulls the future closer, how present moments expand or contract depending on attention and experience. Psychological time flows differently from physical time, creating a private universe within each mind. Though the cosmos governs the mechanics of time, our lives shape its meaning. And through all of this, the paradox becomes clear. Time is both absolute and relative, continuous and fragmented, universal and intimately personal. It is the silent dimension that carries stars across the sky, galaxies across the void, and consciousness across experience. As you drift gently into stillness, allow this truth to settle softly within you. Asterisk, asterisk, the unknown universe. Asterisk, asterisk, is not only a place of vast distances, but of vast durations, where time shapes every motion, every change, and every story that unfolds within the cosmic night. Light is the universe's quiet storyteller. Every star, every nebula, every distant galaxy communicates through photons, tiny packets of energy that travel across the vastness of space without tiring, without aging, without slowing. As your breath settles into a calm and gentle rhythm, imagine a single photon beginning its journey in the heart of a star. It may take thousands of years to escape the star's dense interior, bouncing endlessly between particles. But once it reaches open space, it moves freely at the cosmic speed limit, carrying with it the memory of its origin. Light becomes the universe's messenger, revealing what distance and time would otherwise hide. As your awareness deepens, picture how photons behave not just as particles, but as waves rippling through space with delicate, rhythmic motion. Their wavelength determines their color, temperature, and energy. Long, slow waves appear as radio light. Short, sharp waves appear as gamma rays. As your mind softens, imagine drifting through this invisible ocean, where waves of different lengths pass silently through each other. The universe glows not only in visible light, but in microwaves, ultraviolet rays, X-rays, and infrared warmth. Each type of light reveals a different layer of cosmic truth. Light is also shaped by gravity. As your awareness deepens further, imagine a beam of starlight passing near a massive galaxy cluster. Instead of traveling in a straight line, The light bends as if space itself were curved. This gravitational lensing allows astronomers to see objects too distant or faint to observe directly. In this way, gravity transforms space into a cosmic lens, and light becomes the tracer that outlines the invisible shapes of dark matter. The bending of starlight reveals the structure of the unseen, showing us how mass sculpts the universe. Yet light also stretches as the universe expands. As your thoughts drift deeper into stillness, imagine photons traveling for billions of years through swelling space. Their wavelengths gradually elongate, losing energy in a process called redshift. By measuring this stretching, scientists can determine how fast galaxies are moving away and how the expansion rate of the universe changes over time. Light becomes not only a messenger, but a ruler, a tool for measuring the evolution of cosmic history. But light also has limitations. As your awareness softens, imagine looking deeper and deeper into space. Eventually, you reach a boundary, the cosmic microwave background, the oldest light the universe allows us to see. Beyond this horizon lies a time when photons could not move freely. In this sense, light both reveals and conceals, illuminating the universe while leaving certain epochs forever hidden. It is a guide, but not an all-knowing one. Even the brightest beams must obey the laws of space-time, and through all of this, the paradox shines gently. Light is the fastest thing in the universe, yet it takes billions of years to reach us. It is both particle and wave, visible and invisible, revealing and limiting. It is the fabric of sight, the language of stars, the archive of cosmic history. As you drift deeper into stillness, allow this truth to settle softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, speaks through light, and every photon is a whisper from across the endless night, a silent message carrying the story of where it has been and what the cosmos has become. Space and time are not separate dimensions, they are threads woven into a single fabric that bends, stretches, and ripples under the weight of matter and energy. As your breath settles into a soft, floating rhythm, imagine space-time as an endless, flexible sheet extending quietly in all directions. Planets, stars, and galaxies rest upon this sheet, curving it gently beneath their mass. This curvature is what we feel as gravity. A planet orbits a star, not because it is pulled by an invisible force, but because the star has reshaped the stage beneath it, guiding the planet along a natural path through warped space. As your awareness deepens, imagine drifting across this cosmic fabric, watching the gentle depressions formed by stars and black holes, each one sculpting its surroundings like stones pressing into a stretched membrane. Near massive bodies, the curvature becomes steep, time itself slows, distances contract, and the rules that govern motion shift subtly. As your mind softens further, picture a clock placed at the edge of a deep gravitational well, ticking slower than one far above it. Time is not uniform. It stretches and compresses like the fabric that carries it. Ripples can travel across this fabric too. As your awareness drifts deeper, imagine two black holes spiraling toward one another, their motions sending gravitational waves rippling across space-time. These waves stretch and squeeze the cosmos as they pass, distances shifting by amounts smaller than an atom, yet detectable across millions of light years. They are the universe's quiet tremors, revealing cataclysmic events through gentle whispers carried by the fabric of reality itself. Every ripple is a message written not in light, but in geometry. The shape of the universe as a whole depends on the balance between matter, energy, and expansion. As your thoughts drift deeper, imagine three possibilities. A closed universe curving back on itself like the surface of a sphere. An open universe expanding endlessly like a saddle-shaped plane. Or a flat universe where geometry balances delicately between the two. Observations suggest our universe is nearly flat, its curvature so subtle that only the largest cosmic measurements can reveal its shape. Yet even in flatness, space-time remains dynamic, evolving with the expansion driven by dark energy. On the smallest scales, space-time may behave very differently. As your awareness softens further, picture the quantum realm where the smooth fabric of the cosmos dissolves into frothy fluctuations, tiny, ever-changing structures that flicker between existence and non-existence. Some theories propose that space-time itself emerges from deeper principles, such as entanglement or informational networks woven at the smallest possible scales. In this picture, geometry is not fundamental. It is born from relationships, the way patterns arise from countless interconnected threads. And through all of this, the paradox settles quietly. Space-time is both the stage on which the universe unfolds and a participant in every event. It is soft enough to ripple, strong enough to shape galaxies, flexible enough to bend around stars, and mysterious enough to hold secrets we have not yet uncovered. As you drift gently into deeper stillness, allow this truth to rest softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, is built not on empty space, but on a living fabric, one that curves, flows, vibrates, and evolves, carrying the story of everything that has ever happened or ever will. Magnetic fields stretch across the universe like unseen threads, shaping the motion of particles and guiding cosmic structures with silent precision. As your breath settles into a slow, gentle rhythm, imagine drifting through interstellar space, an expanse that seems empty yet is interwoven with faint magnetic lines. These fields are not strong enough to feel directly, but they influence everything from the birth of stars to the glow of distant galaxies. They act as the universe's subtle choreography, directing charged particles in graceful spirals and steady flows across unimaginable distances. As your awareness deepens, picture the magnetic field of a single star like the Sunday. It extends far beyond the visible surface, twisting and stretching as the star rotates. As your mind softens further, imagine plasma superheated, electrified gas moving along these field lines, forming arcs and loops that dance across the stellar surface. When magnetic lines snap and reconnect, they release bursts of energy that send particles streaming through space. These events, called solar flares, shape the space environment around planets and influence cosmic weather throughout the solar system. Magnetic fields also sculpt the birthplaces of stars. As your awareness deepens, imagine a cold molecular cloud slowly collapsing under gravity. Without magnetism, this collapse would be chaotic and uncontrolled. Instead, magnetic fields thread through the cloud, slowing its collapse and guiding material into rotating disks. These disks eventually form new suns and planetary systems. Magnetism helps determine the spin of newborn stars, the size of their disks, and even the distribution of planets. The universe's invisible threads guide the formation of entire worlds. On galactic scales, magnetic fields weave through spiral arms, helping structure the flow of gas and dust. As your thoughts drift deeper, Imagine cosmic rays, high-energy particles traveling near the speed of light, spiraling along these enormous magnetic pathways. They move through galaxies like silent travelers, influenced not by gravity alone but by the unseen magnetic skeleton that permeates the cosmos. In this way, magnetism influences star formation rates, galactic rotation, and even the distribution of interstellar matter. Even the vast cosmic web, the large-scale structure of the universe, may be threaded with magnetism. As your awareness deepens further, imagine faint magnetic fields stretching between galaxy clusters across millions of light-years. These fields are incredibly weak, yet their influence accumulates over enormous distances, shaping the motion of plasma, guiding cosmic jets, and helping regulate the flow of intergalactic gas. Magnetism becomes the quiet architect behind phenomena we cannot see directly, but whose fingerprints are everywhere. And through all of this, the paradox emerges gently. Magnetic fields are among the universe's most influential forces, yet they are also among the most hidden. They sculpt galaxies, shape stars, and guide particles, all without producing light or sound. They are the silent companions of gravity, working endlessly in the background. As you drift gently into deeper stillness, allow this truth to settle softly within you. Asterisk, asterisk, the unknown universe. Asterisk, asterisk, is held together not only by what we can see, but by invisible threads, magnetic pathways that connect stars, galaxies, and the vast spaces between them. Space is never truly empty. Even in the deepest voids, streams of particles drift silently across the universe, remnants of ancient stars, violent explosions, and energetic processes we barely understand. As your breath settles into a soft, slow rhythm, imagine floating in interstellar darkness while an invisible rain passes through you. These particles, known as cosmic rays, arrive from every direction at nearly the speed of light. They are fragments of atoms, protons, and exotic particles accelerated by forces far greater than anything we can create on Earth. Though invisible, they form a constant connection between distant corners of the cosmos. As your awareness deepens, picture a supernova explosion sending shock waves through surrounding gas. Within these expanding waves, charged particles spiral through magnetic fields, gaining energy with each turn. As your mind softens, imagine these particles being flung into space with tremendous force. Some leave their home galaxy entirely, traveling for millions or billions of years before reaching another world. When a cosmic ray finally strikes Earth's atmosphere, it generates a cascade of secondary particles that rain softly toward the ground. Each particle is a messenger from a distant star. Even more mysterious are ultra-high energy cosmic rays, particles so energetic that their origins remain unknown. As your awareness deepens further, imagine a single proton carrying as much energy as a thrown baseball, yet compressed into a microscopic form. These particles may come from supermassive black holes, colliding galaxies, or phenomena we have not yet discovered. Their paths are twisted by magnetic fields, making it difficult to trace them back to their sources. They are, in many ways, the riddles of astrophysics, clues to cosmic processes far beyond current understanding. Neutrinos form another invisible current flowing through the universe. These ghost-like particles pass through matter effortlessly. Trillions pass through your body every second without leaving a trace. As your thoughts drift deeper, imagine neutrinos created in the heart of a star's fusion core or during the collapse of a supernova. They travel straight through planets, stars, and galaxies, almost as if space-time were transparent. Detecting them requires enormous, silent detectors buried deep under ice or water. When a neutrino is finally captured, it reveals secrets from places light cannot escape. Cosmic particles also shape the environments around planets and stars. As your awareness softens, imagine solar wind, a stream of charged particles flowing from the sun interacting with Earth's magnetic field. These interactions create auroras, shimmering curtains of green, red, and violet light dancing across polar skies. On distant worlds with stronger magnetic fields, auroras may blaze with far greater intensity, painting alien skies in colors we cannot yet imagine. Particles, though small, shape worlds on a grand scale. And through all of this, the paradox becomes clear. The universe's most powerful travelers are also its quietest. Cosmic rays, neutrinos, and high-energy particles fill the cosmos with motion, yet they remain unseen, passing through matter without sound or light. They are both ephemeral and eternal, delicate and violent, rare and abundant. As you drift gently into deeper stillness, allow this truth to settle softly within you. Asterisk, asterisk, the unknown universe. Asterisk, asterisk, is alive with invisible currents, flowing silently through every corner of space, whispering stories of distant explosions, ancient stars, and energies beyond imagination. The universe began with only the simplest ingredients: hydrogen, helium, and trace amounts of lithium. As your breath settles into a soft, drifting rhythm, imagine this early cosmic mixture spreading across space like a thin, glowing mist. There were no metals, no oxygen, no carbon, nothing yet capable of forming planets, oceans, or living organisms. All heavier elements, everything that makes worlds solid and life possible, had to be forged later through the creative violence of stars. The cosmos is, in a sense, an enormous factory of alchemy, continuously transforming simple atoms into complex building blocks. As your awareness deepens, picture a star's core as a nuclear furnace. Over millions or billions of years, lighter atoms are fused into heavier ones, hydrogen into helium, helium into carbon, carbon into oxygen. As your mind softens further, imagine these fusion reactions releasing tremendous energy, allowing the star to shine steadily across the darkness. The periodic table begins to fill slowly, step by step, as stars convert the universe's first elements into materials that will one day form rocky planets, metal-rich asteroids, and organic molecules essential for life. But stellar fusion can only go so far. As your awareness deepens, imagine a massive star reaching the limit of its nuclear capacity. Once iron forms in its core, the process becomes unsustainable. Fusion stops. Gravity overwhelms the star, and it collapses in on itself. In the explosive chaos of a supernova, temperatures and pressures rise high enough to create the heavier elements: gold, platinum, uranium, and beyond. These elements, flung into space at extraordinary speeds, seed the galaxy with the raw materials needed for future worlds. The most precious substances in the universe are born from stellar death. Neutron-star collisions also play a vital role in cosmic chemistry. As your thoughts drift deeper, imagine two dead stars spiraling together, their dense cores merging in a burst of energy so powerful that gravitational waves ripple across the fabric of space-time. In the intense neutron-rich environment of this merger, Heavy elements are forged in vast quantities and scattered like cosmic dust across light years. This process explains the existence of many rare elements on Earth. The jewelry we wear and the metals in our technology carry the signature of these ancient, cataclysmic events. Over billions of years, these elements become part of new star-forming clouds. As your awareness softens, imagine dust grains composed of silicates, carbon compounds, and metallic fragments drifting through space. Gravity gathers them into nebulae, where they eventually join new generations of stars and planets. The oxygen in Earth's oceans, the calcium in our bones, the iron in our blood, all originate from stars that lived and died long before the sun existed. The atoms within you are older than Earth itself, forged in explosions that occurred across distant regions of the galaxy. And through all of this, the paradox emerges. The universe creates complexity through destruction. Stars must die for planets to form. Collisions must occur for rare elements to exist. Chaos must precede order. Every atom, heavier than helium, is the result of a cosmic chain of events stretching back through untold ages. As you drift gently into deeper stillness, allow this truth to settle softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, is not only a place of vast structures and mysterious forces, but a realm of continuous transformation where the ingredients of life are written in the ashes of ancient stars. Even with all we have discovered, the universe remains filled with puzzles, phenomena so strange, so unexpected, that they challenge the very foundations of physics. As your breath settles into a slow, drifting rhythm, imagine standing on the edge of human knowledge, looking out into a night sky dotted not only with stars but with unanswered questions. These mysteries linger like faint signals in the dark, inviting us to look closer while reminding us of how little we truly understand. The unknown is not a distant frontier. It is woven into the universe we observe every day. As your awareness deepens, picture fast radio bursts immensely, powerful flashes of radio waves lasting only milliseconds. They erupt without warning from distant galaxies, carrying more energy than the sun emits in days. Their origins remain uncertain. Some may come from magnetars, others from colliding stars, and still others from processes we have not yet imagined. As your mind softens further, imagine these bursts as cosmic Morse code brief, brilliant pulses that illuminate the deep unknown for an instant before fading back into silence. Dark matter and dark energy, though discussed and measured, remain fundamentally mysterious. As your awareness deepens, imagine trying to map the universe while being able to see only a small fraction of its contents. 95% of the cosmos consists of something we cannot touch or observe directly. We feel their gravitational and expansion effects, yet their true nature escapes us. This unseen majority of the universe is a constant reminder that our understanding rests on a narrow island surrounded by a vast ocean of uncharted truth. Another mystery lies in the behavior of galaxies at cosmic scales. As your thoughts drift deeper, imagine distant galaxies rotating in ways that defy the expected influence of visible matter. Their motion suggests either missing mass dark matter or a need to revise our laws of gravity. The universe hints at answers without fully revealing them, offering equations that leave room for new physics waiting to be discovered. Each unexplained rotation curve becomes a whisper urging us to look beyond what we currently know. Even the structure of the universe raises questions. Some regions appear too large, too empty, or too organized to fit neatly within existing models. As your awareness softens, imagine colossal cosmic voids, unusually aligned clusters, or temperature anomalies in the cosmic microwave background. These features might be coincidences, or they may point to new physics, earlier cosmic cycles, or even interactions between universes. The cosmos carries scars and signatures we have yet to decipher. And through all of this, the paradox stands quietly. The more we uncover, the more mysteries emerge. Knowledge does not eliminate the unknown, it expands it. Each discovery adds depth to the darkness, revealing new questions that stretch beyond imagination. As you drift gently into deeper stillness, allow this truth to settle softly within you. Asterisk, asterisk, the unknown universe, asterisk. Asterisk is not meant to be fully understood. It is meant to be explored one mystery at a time through the soft, unending curiosity that has carried humanity toward the stars since our earliest nights under the sky. The universe is larger, older, and more intricate than anything the human mind evolved to comprehend. Yet as your breath settles into a soft, drifting rhythm, imagine standing beneath a night sky where every point of light is a doorway, some leading to galaxies, others to mysteries, and many to realms we have not yet found the language to describe. In exploring the cosmos, we are not simply gathering facts, we are touching the edges of existence itself. Every observation, every discovery, every unanswered question is a reminder that the unknown is not an obstacle, but a horizon, one that recedes as we draw near, inviting us ever deeper into wonder. As your awareness deepens, picture all the cosmic structures you have drifted through: spirals of starlight, glowing nebulae, silent voids stretching across millions of light years, and the dark halos that cradle entire galaxies. Imagine the invisible forces, gravity, magnetism, dark matter, dark energy shaping the universe with a quiet but unrelenting precision. These forces do not speak, yet they tell stories. They do not reveal themselves, yet they guide the behavior of everything that exists. Through them, the universe expresses its deepest architecture, showing us that order and mystery coexist in delicate balance. The cosmos is ancient beyond measure. As your mind softens further, imagine the first light of creation still drifting through space, the afterglow of the Big Bang washing gently over everything. That light carries within it the memory of beginnings of a universe that emerged from a state so dense, so hot, that our equations fracture at its threshold. Stars were born, died, and were born again. Galaxies collided and reformed. Elements forged in destruction became the seeds of life. The universe is not static, but evolving, breathing across billions of years in cycles of creation and transformation. And yet, despite its immensity, the universe touches each of us intimately. The iron in your blood was formed in a collapsing star. The oxygen you breathe was shaped in a stellar core. The calcium in your bones was forged in ancient cosmic fire. As your awareness deepens, imagine how every atom in your body once belonged to places far beyond Earth nebulae, supernovae, or merging neutron stars. You are not separate from the cosmos. You are a continuation of it, a brief and luminous expression of the same laws that sculpt galaxies and shape space-time. But the greatest truth the universe reveals is that mystery is not a barrier, it is an invitation. As your thoughts drift deeper into quiet, imagine the countless unanswered questions that fill the cosmic dark. What lies beyond our observable horizon? What is the true nature of dark matter and dark energy? Are there other universes, hidden like reflections behind a mirror we cannot yet see? These questions are not closing notes but opening doors. The unknown is vast, but so is the human spirit that seeks to understand it. And through all of this, one paradox remains. We are tiny, fragile beings on a small blue planet, yet capable of grasping the structure of galaxies, the behavior of black holes, and the echo of creation itself. As you drift gently into stillness, allow this truth to settle softly within you. Asterisk, asterisk. The unknown universe, asterisk, asterisk, is not something outside of us. It is something we carry within. Every moment of curiosity, every spark of wonder, every quiet breath beneath the night sky connects us to the endless, unfolding story of existence. And though the universe is vast and mysterious, it welcomes our questions, invites our awe, and whispers to us through every star. Asterisk. There is always more to discover. Asterisk.